Hey guys, Dr. Brown here with Kubo Math, and tonight for all you partial fraction freaks out there, we're going to try to integrate cosecant cubed x using partial fractions. Okay, now we can do this other ways, but hey, let's make it cool and do this by partial fractions. Now you know in partial fractions there's 4 rules that we've been using. There's a form associated with linear factors, another one associated with repeated linear functions, another form then when you have quadratic functions or repeated quadratic functions. Now it could be a mix of the two. So you know we're using partial fractions when we're dividing by some polynomial that we can factor. Now as you can see here, we just have the integral of cosecant cubed dx. Now we know that's 1 over sine cubed. Now my dilemma here, I could take out one of the sines. Now I have 1 minus sine squared, or excuse me, 1 minus cosine squared times sine. But how do I factor that into something I can work with? So the key to this entire problem was I'm going to multiply my 1 over sine cubed x by 1, and I'm letting my 1 be sine x over sine x. That gives me sine x over sine to the 4th, which is sine squared sine squared. Hey, so now I can take that sine x, change all my sine squared into 1 minus cosine squared x times 1 minus cosine squared x. Now at this point I decided I'm going to let u equal cosine x. And this works out well because by multiplying this by sine x over sine x, I ended up with the derivative of this function in the numerator. So, which worked out great. So okay, cosine x is u, du is minus sine x dx. So if I solve for dx, then that's du over minus sine x. That allows me, when I put in my 1 minus u squared times 1 minus u squared, still have the sine x, but the dx then was du over negative sine x. The sine x is cancelled. My negative now is here. Negative 1 times, if I FOIL this out, I get negative 1 over 1 minus 2u squared plus u to the 4th. Now, if I were to try to find the roots of that equation, of the denominator, which is what we're really after here, we're trying to understand, can I break this into a parentheses multiplied by another times another such that I can utilize the concept of partial fractions to solve that. So if I let u to the 4th minus 2u squared plus 1 equals 0, and I'm trying to find the roots, if I just guess u equals 1, 1 to the 4th is 1 minus 2, u squared is still 1, so 1 minus 2 is negative 1 plus 1 is 0. Hey. So u equals 1 is a solution for that. So that means u minus 1 equals 0. Okay, now get into some long division here. I can take and expand this function u to the 4th plus 0u cubed. I don't have any u cubed terms. Minus 2u squared plus 0u. There were no u to the 1st power terms, plus 1, that divided by this u minus 1 that we've just calculated. So if I go through that long division, and I know many of you, this is not something you do every day now, in our time, yes, all the time. So u to the 4th divided by u gives me u cubed. U cubed times u to the 4th, or u is u to the 4th. U cubed times a negative 1 is negative u cubed. Put the parentheses around that because I'm subtracting. So u to the 4th minus u to the 4th is 0. 0 minus a negative is plus a positive, so that gives me a u cubed. Bring down the negative to u squared. Okay? U squared times u gives me this u cubed, or I could have just said u cubed minus u gives me u squared, but multiply those out, gives me u cubed. U squared times the negative 1 is negative 2u, or negative u squared, sorry. Again, parentheses around it because I'm subtracting. And that ends up giving me negative u squared, bring down 0u. Repeat that process again and again, and I end up with u cubed plus u squared minus u minus 1, or plus, minus 1, sorry. So that would be these terms here. U minus 1 times that, what we just ended up with, gives me this u to the 4th minus 2u squared plus 1. If I were to cover up this u minus 1, can I factor? Are there any other factors inside that one? Well, if I guess 1 again, 1 cubed, 1 plus 1 minus 1 is 0. So there's another u minus 1 term in that. So that gives me 2 of those. So if I were to divide again this new u minus 1, keep in mind that one's covered up, divide that into u cubed plus u squared minus u minus 1, I get u squared plus 2u plus 1. So I have u minus 1 times u minus 1 times this u squared plus 2u plus 1. Well, I can factor that readily. That's u plus 1 times u plus 1. So I end up with the terms in the denominator of u minus 1 squared times u plus 1 squared. So keep in mind I had that negative 1 right here. So the integral of negative 1 over u minus 1 squared times u plus 1 squared, integrating that with respect to u equals, remember the rule for repeating linear factors. I need a partial fraction for every power of that repeated term. So in this case it's to the 2nd power. So I need one of those, a over u minus 1 to the 1st power plus b over u minus 1 to the 2nd power. It's the same for the u plus 1 squared term. C over u plus 1 to the 1st power plus d over u plus 1 to the 2nd power. And I'm integrating those 4 partial fractions with respect to u. Okay, so there's an algebraic term to this. If I take and multiply both sides of this by u minus 1 squared times u plus 1 squared, that cancels over here and I'm left with just the negative 1. If I repeat that on the other side, you can see one of the u minus 1 terms cancel. I'm left with one of them, but I'm left with all of the u plus 1 squared. Same concept here. I'm multiplying u minus 1 squared times u plus 1 squared times b over u minus 1 squared. The u minus 1 squared terms cancel. I'm left with u plus 1 squared. So I repeat that same process all the way through, and I'm left with this equation. Okay, so now I'm just going to guess values for u and work through it. So in this case, let u equal negative 1. So anywhere there is a plus 1, that negative 1 term is going to cancel that out. So it cancels out my a, that gives me a 0, cancels out the b terms, cancel out the c term, because negative 1 plus 1 is 0, 0 times anything is 0. So I'm left with negative 1 minus 1 is a negative 2 squared is 4. So I'm left with a 4d. Negative 1 equals 4d, so negative 1/4 equals d. I repeat that same process. I let u equal 1. Go through that again. I end up with negative 1/4 is b. I let u equal 0. And now in this case, I'm substituting in my values that I have for b and d. For example, let u equal 0. So 0 minus 1 is negative 1, 0 plus 1 is 1, 1 squared is 1. So I'm left with negative 1 equals negative a, and then b was negative 1/4. 0 plus 1 is 1, 1 squared is 1, so negative 1/4 times 1 plus c times negative 1 squared, which is 1. 0 plus 1 is 1, so 1 times c just gives me c. And then d was negative 1/4. 0 minus 1 is negative 1. Negative 1 squared is 1, so that's just a negative 1/4. So I have a negative 1/4 and a negative 1/4. That's negative 2/4. So minus a minus 2/4 plus c. I manipulate that around. I end up with minus 1/2 equals minus a plus c. I go through the same process again by letting u equal 2. And I end up now with two equations, two unknowns. I multiply the first one by negative 1. I end up solving for a, that's 1/4. Then c is negative 1/4. So a is a positive 1/4. B, C, and D all are negative 1/4. Now then, I can plug my A, B, C, D into this equation here, or into this one. So I have 1/4 times the integral of 1 over u minus 1 du minus 1/4 the integral of 1 over u minus 1 squared minus 1/4 the integral of 1 over u plus 1 du minus 1/4 the integral 1 over u plus 1 squared du. Okay, so this one's just 1/4 natural log u minus 1. And this term is u minus 1 to the negative 2 du. So we can work with that. We increase that integral by 1, gives me a negative 1 divided by negative 1. That cancels out. That negative makes it positive. So 1/4, 1 over u minus 1, it's the same here. Negative 1/4 natural log u plus 1. And this one's just like the other one, plus 1/4, 1 over u plus 1. Now then, I'm trying to get a common denominator. So I reached a conclusion that would be 4 over u minus 1 u plus 1. So then I go through and I solve for those, whatever I needed to multiply this by. For example, in this 1/4, I had a 4 in the denominator already. So I needed to multiply this one by u minus 1 over u minus 1, which is 1, times u plus 1 over u plus 1, which is 1. That gave me then the terms in the denominator. And I go through that same process with each one. You guys obviously know how to get a common denominator. Now I collect terms, I cancel out where I can, and I'm left with 2u over 4, well, which was my common denominator. But on this other piece, these terms canceled. I'm just left with 1/4 natural log of u minus 1 over u plus 1, because I had that minus that natural log term, so that ended up in the denominator of this one. Now at this point, I FOIL this out. I end up with, and then substituted back in, recall, way over here, we said u was cosine x. So I had 1/2 cosine x over cosine x squared minus 1, if you FOIL that. Now, I should note, before I lose track here, cosine squared x minus 1, parentheses, cosine squared plus sine squared. So if I distribute that negative inside, I get cosine squared minus cosine squared minus sine squared. That's where this minus sine squared x came from. Plus the natural log cosine x minus 1 over cosine x plus 1 plus c. That's we've made that problem more complicated than it really needed to be, but we're working on partial fractions here locally, so this ended up being a good exercise. Actually, we ran across, one of the students came up with a book, I think it was copyrighted in 1906. It has some excellent problems in it. I mean, excellent. This actually was one of them. And I had to noodle around on that for a while to be able to get that answer, I'll have to admit. Okay, why are we doing this? Hey, together we're trying to build a better tomorrow. And do that how? Do that through math. Keep studying, guys, okay? Keep working these crazy partial fraction problems and expand your mind, okay? That's all for now, and we'll talk to you next time. Thanks.